Welcome. In this particular two-part demo, we're going to have a look at a collision detection demo, and also one that's been set up to illustrate a very crude platform-esque style of game. So it's going to be this particular one here where we have a number of platforms, we have a player-controlled entity, and we can do then collision detection with the different entities that we have within the world, and then sort of be able to control our motion or movement through the particular level. So it's two parts. In the first part, this part here, we're going to have a look at how this all fits together from an architectural perspective, and in the second part we're going to specifically look at the collision detection and also the collision response components of it. In terms of the architecture, it actually fits within the same architecture that we looked at whenever we were exploring the steering example. So you may want to sort of watch that one or make sure you're familiar with that one, because a lot of the components I'll go over reasonably quickly in this particular one here, and specifically we'll look at how we've created the collision detection / simple platformer. The trigger point for all of this is within our menu screen, where we had a couple of simple touch areas, and if the player touched upon the collision demo, then we were removing the main screen, or you could just set it inactive, whatever you want to do, creating a new collision demo and then adding that particular one into it. For the actual classes that we have within this demo, we have our main game screen, which is the collision demo game screen. We also have then the player sphere, this particular entity down here, and we have a number of simple controls, so for moving left, moving right, and for jumping up. You might ask, okay, so what are these other brick-like structures, the platforms, where are they? In that case, they are just simply game objects that we have created within the world. So we're drawing upon some of our basic underlying behavior for simple objects or simple sprites, and then extending them where appropriate for this particular illustrative demo. We'll start off first of all looking at our collision demo game screen. So it is a type of game screen. So just as a reminder here, we have an activity that contains a single fragment. That fragment is scaled to over the full display. The fragment contains a single view, a custom view that we draw our game to. And at any point in time you have one active game screen, and that game screen is asked to draw itself to that particular view, and it's also asked to update itself as well. So this is the particular game screen then that will replace the menu whenever we click on that. So things that we have within this here, we're defining just how big the world is. So in this case we're saying that it's 2,000 units wide, and it's a total of 320 units high. And this is just ones that we sort of arbitrary values that have been picked to sort of bound our objects within it. We have next to that then a ScreenViewport and also a LayerViewport. So the ScreenViewport will determine which bit of this 2000 by 320 world we get to see. So 2000 by 320 is too big to display all at once. So we're going to simply display a 480 by 320 chunk of that particular world. And it's being displayed onto the screen. And you can see here for the screen, that as the character moves, that we are displaying a 320 by 480 chunk. This is the emulator is not using a 3:2 aspect ratio. This is a 3:2 aspect, either ScreenViewport and also LayerViewport. So we have white bars displayed down the sides here where we're not showing that particular bit of the world. And again, you could have had a more sophisticated way of setting this up so that you sort of change the ScreenViewport so it have the right or matching aspect ratio to what was available on the screen. We have three simple controls: move left, move right, and jump up, and we're storing them within a list, an array list in particular. The reason we do that is that, for example, when we're drawing things out, we just simply want to say there's a list of controls, iterate through that list, and called draw on each of them. So it's going to simplify a few of the methods where we want to do the same type of operation on all of our controls, for example, drawing them out. And as opposed to having to hard code each one in, we just have a piece of code that iterates through a generic list and draws whatever is inside it, for example. Game objects then, or platforms that we have available there, they're just simple game objects. They're going to have a position, they'll have a size, it'll give them a bound that we'll do for collision detection. They will have a graphic, and that's all the functionality that these things need to have. So we didn't have, for this simple demo, the need to extend GameObject into a platform class. Although I would suggest within your game, if you know, it probably does make sense in most games to have a specific platform class, because then you can encapsulate a number of different things or a number of different components within it and have the flexibility for different types of platforms. But simple demo here, we never bothered doing that. We've got a player instance. So at the top of our game screen then, we're defining useful things, the size, the viewports, and all of the objects that notionally live within that particular screen, the player, the platforms, and a few controls. Here's our constructor. So in the constructor, you'll be expecting us then to set all of those things up, to set up the viewports, to define and to create the different objects in the platform and the player, and to give them their positions within our defined world. And that's what we're going to do within this one. So firstly, we are creating our viewports. The LayerViewport has a fixed size. And just as a reminder, first two components was the midpoint, so 240 across, 160 up. The next two were the half width extents. So it's 240 that way and 240 that way, so 480 in total and 320 up the way. So it's that's just the size of our LayerViewport. Our ScreenViewport, we're actually using a method here to create a 3:2 aspect ratio viewport. And we pass in the game that we're running on, the fragment, and we pass in the viewport instance, which is to be populated. So if we have a look at that class, down here at the bottom. So we have it here. It is simply a method. It will create a 3:2 aspect ratio. Some devices will automatically, their screen automatically will be will physically be a 3:2 aspect ratio. It'll use the full available screen. Other devices, a lot of Android tabs, 16:10, 16:9. So in that case, we're working out, okay, well, what is the actual screen width divided by the screen height? That gives us the aspect ratio. If it is greater than well, in terms of width divided by height, greater than 1.5, which is 3/2. So for example, 16:10 and 16:9 are. Then we know it's one of those aspect ratios, and we're going to create two, if you like, blank bars down the left and the right hand side of the screen. So we define our view and our width accordingly. If we were running, for example, on a 4:3 aspect ratio, which will have a value, 1 divided by the other less than 1.5, in that particular, or indeed if it is matching, in that particular case, we're going to define our width and height this way. And if it's less than 3:2, then we'll have blank bars at the top and bottom of the screen. So it's, because this is the type of thing you probably want to do often enough, it's been segmented out into its own particular helper class. So we create our viewports, a bit of the layer and something on the screen that we're going to draw to. We load in all of the graphics that we're using within this particular screen. And there's 5 in total there, so there's not too many. We're adding them into our asset manager. So the game screen has access to the game has access to the asset manager, so we get our game, we get our asset manager, and we're asking it to load and add in bitmaps, so that we only, whilst we may have lots of platforms, we'll only ever have one loaded platform image that our platform instances will then all use. As the game becomes bigger and more sophisticated, this list here is going to grow, and you might get to a point where for your level you're loading in 100 different bitmaps of different size and of different functions. At that point, you might want to think about doing a different approach here. This is just hard-coded in. A more flexible approach would be to have a method that will load in a list for example, from an XML file or just from a text file, and parse through that list for the name of the given name for the asset and the location of the asset, and then just load these things in dynamically. It means that you're sort of separating out more of a data-driven approach as to what it is you're loading in. We're then going to create the touch controls. Now, one thing to say about the touch controls, you can see there as I move about the game screen that things like what is visible within our 3:2 aspect ratio, it changes as the viewport changes. But you'll notice that, for example, for the controls, they're not necessarily within this 3:2 aspect ratio. And we're making a distinction. For the controls, these are things that we touch. So we're interested in touch events. Touch events occur in terms of screen coordinates from 0, 0 over here to the width and the height of the screen. So when we are displaying these particular buttons, the location that we give them, we want to say their location directly on the screen, whereabouts they are on the screen. Whereas for the other ones, they have a location in terms of our game world, if you like, in terms of that 2000 by 320 region. These always have a fixed location on the screen. So we are creating them here. We need to know the size of the screen so we can appropriately position them. And we're creating the left one down here, the right one, and the jump up one over in this particular size. They are positioned relative to the overall size of the screen. So depending on the resolution, it'll change the position. The one thing this doesn't do, because it's a simple demo, is to change the size of them. There's no scaling involved in this here. So that if you were to run this demo on a higher resolution device, you would still have the buttons in these respective locations, but they would be smaller. And if you wanted to do this properly, what you should do is to look at the actual device, get the number of pixels per inch, if you like, and then calculate, okay, I want to have, for example, a 1 centimeter by 1 centimeter region, because it's a physical contact you're looking at, and the player's fingers and thumbs aren't going to scale in size. So you'd actually have to calculate physical region, what does that equate to in terms of a pixel size, and then to position and to scale this based on that particular pixel density and size. But there, this is just a simple way of illustrating how you can get a few controls on the screen. We create our player, then we create the platforms, list of platforms here. We're going to have, as you can see in the demo, a whole bunch just along the bottom, and they always appear along the bottom. And then we're going to have a bunch of ones that are just created at random. So each time you go in, you've got a random bunch of them being created. So this gives us our base platform. To be honest, not a great way of providing a solid ground. There are better ways, and I'll talk about that when we look at part 2. And these ones here are just platforms that happen to be positioned about. So you can check this yourself. All we're doing is iterating through for the ground one, then iterating through and randomly creating, within the confines of the level, a number of other platforms. This brings us to the end of the constructor. So here we configured all of the things. We've set up viewports, we've loaded stuff in, we've positioned our objects in terms of the controls, the player, and the platforms, and we've created them all as well. So things are all set up, ready to go. So when we're updating our layer, we have all of the things that we want to update. When we're drawing it, we have all the things that we want to draw. When we're looking at updates, we basically scroll down. You can see that there's not a huge amount. It more or less fits on this screen here. And most of this code for the update here is basically making sure that the player and the viewport can't leave the overall screen. So we update our player first of all. We say, okay, how much time's elapsed. We are going to our touch controls. Actually, let's just have a look at the touch control at this point. So simple control. It's a type of game object, so it has a position, has a bound to it, has an image. And when we create a simple control, we give it X and a Y, a width and a height. And we're assuming there that these are screen coordinates. And we give it a bitmap and the screen to which it belongs. It doesn't have an update method. It has an isActivated method, or is or has it been touched method. and we have a draw method. For the draw method, it says here, assumed to be in screen space, so just draw the whole thing. There's no messing about with layer viewports here or stuff like that. For control, you assume it's visible on the screen, so just draw it straight to the screen, so that's what we're doing. The is activated, the job of this method is to work out, has the player touched the particular control? And one of the things to note here is that, okay, emulator only supports multi-touch, but if this were running an actual device, you'd sometimes want the player to be going to the left and sort of clicking on jump at exactly the same time. So this has to support multi-touch in terms of its behavior. So is activated. What we do is this is a game object. The game object knows what screen it belongs to, so we go to our screen. The screen knows which game it belongs to, we go to the game. And the game is the entity that looks after our input manager. So this game object gets access to the input manager and has to do it through that particular linked chain, but nonetheless it can do it and it gets access to it. This is a game object. All game objects have a bound and have a get bound method where we can get our own bound. So we're getting our bound out. We need our bound because this is what we're going to work out has somebody touched us. We're then going through, and this sort of assumes you've explored this in terms of the underlying architecture, that within our main input class here, we have a touch handler, and inside the touch handler it defines the maximum number of simultaneous touches that you can have on the screen. In this case it's set to a value of 10. So our touch handler, which the input manager uses, says I can support up to 10 simultaneous touches, or touch IDs. So we're going to go through to check, do we have a touch with a touch event with an ID of 0, 1, 2, 3, 4, all the way up to our maximum. And if we do have a touch with an ID of 0, 1, 2, 3 as we iterate it through, then we check to see for that particular touch event, has it occurred, we're getting the X, we're getting the Y, has it occurred within the particular bound? If it has occurred, that basically means at least one of the digits, if there's multiple ones have been touching the screen, one of them has fallen within our particular region. And we don't care which event it is, we just simply care that something has actually notionally touched us. That's the case, return true. We say yes, we have been activated. The first one's good enough, we're happy to return then. If none of them are either active or have touched us, then we say nope, false, we haven't been activated for this particular update. Right, so that was being used within our update here. So we update the player. We're checking to see, well, do we want to move left? Do we want to move right? Are we suggesting we want to jump up? And that's our way of passing into the player or input, or any input that we've received from the actual player, him or herself, into the player class. We also pass into the player the list of platforms. So it's the time that's elapsed, input from the actual player who's playing the game, and the list of platforms, because we'll want to maybe try to avoid those platforms. What we have after this then is a test to check that the player cannot leave the confines of the world, that the player is restricted to the world. And we'll comment this out. At this point, after that, we are then changing our viewport. Now, let me just modify this slightly. So I'm removing a bit of the functionality. So we're still updating the player, but we're letting the player go anywhere. And as the player moves, we are changing the viewport. So the viewport X and Y is wherever the viewport, or wherever the player is. So the viewport always focuses, looks at the player. And this bit down here was another check to make sure that the viewport can't leave the level itself. So we made a few changes. We'll just see what effect those changes have, and why we actually wanted to put in that additional code. So we run it now, and you can see it actually looks different. Before we had our platforms down at the bottom because the layer viewport, it couldn't leave the screen. Now the player is always in the center. So no matter where the player goes, it will, well, it's now stuck. No matter where the player goes, it's always going to appear. If I jump up, then the player stays in the center and the world seems to go up. Now before, when I was running it, the world initially stayed the same and it looked to be the ball was bouncing up. In this case, it seems to be, well, the ball does look to be bouncing up, but it's always visible in it. Because I don't have any restriction, I actually can fall notionally out of my world. I'm not restricted to it. So I mean, the viewport's looking at me, but I'm constantly falling down now. So it's important to put in some control on these particular elements. So this one here, if I introduce this, basically checks to say, okay, has the player tried to move less than 0, it's the left-hand side, or greater than the width, or below the bottom, or greater than the top? And if that's the case, then I actually physically change the position of the player. I say, no, you can't move in that direction, I'm going to shift you back. So the player always falls within the world. So we'll run this one now. And if I move over here, I'm stuck. I can't actually leave the world. I still have my camera, and my camera's still focusing on the player. So as I move around and jump up and things like that, the viewport will follow the particular player. For some games, that's exactly what you want. You want to always have it more or less in the center and to track about as the player moves. This particular one here, though, we were also changing the viewport. So the viewport, similar to the player, the viewport can't leave the layer as well. The viewport is always showing a bit of the world. We can't position the viewport. These checks make sure that we can't position the viewport so that it tries to show a bit of the world outside of it. So we're always going to see a bit of the world, and that's what that does. So adding that particular one in, and we run it, it gets back to what we had before in terms of the activity. That here we get to see the whole layer. If I jump up now, because my viewport is stuck within this particular confines, it may be, well, it still is actually trying to change its position relative to the player, but it's not able to do that. So it seems to be our world is fixed, and in this case it's more, you see the player jumping up. So depending on the type of interaction that you want to get out of it, that's fair enough. That brings us to the bottom of our update. So effectively update the player, it does the movement, does the collision detection, then we have a few checks to make sure everything is still going to look okay. When we're drawing it out then, we clear the screen, we draw the player, we draw each of the platforms, and we draw the list of controls. These can be drawn in any order. It's important that you draw the controls last. And you can see here we're iterating through our list because we always want the controls to be visible on the top. That's about the only one here that is important by way of draw order. Now, that's all we want to look at within this particular first part. In the second part, we'll have a look at the player class in terms of how the player moves around, and we'll bring into that our collision detector in terms of how we can detect and then react appropriately to some collisions. But that's all going to be in the second part.